Hi, my name's Anthony Roberti, and we are design of the Trout stream.
I'm Samantha Baus.
And I'm Brianna Paulson.
So our project was the design of a trout stream, and the purpose of this project was that a sponsor had contacted us and they wanted a trout stream on the property for aesthetic reasons and to be able to fish. So our problem was to be able to design this artificial trout stream that you can see and have it fully functional and able to support fish life. So Anthony's going to talk about the heating and cooling issues that we had.
Our main challenge was making sure that we could provide 55 degrees Fahrenheit of water temperature for our trout year-round. So our solution was to take the principles of a ground source heat pump, which are used in residential or commercial heating and cooling systems, and as you approach, and the way those systems work is, as you approach depths of 20 feet or greater, the Earth's temperature is a consistent 55 degrees Fahrenheit. And so what we are doing in our design is we're taking the water we are pumping in that stream and we are pumping it at depths of 20 feet. And so that way, as we pump that water, it will have the necessary heat loss to keep that 55 degrees in the hot summer months and also in the cold winter months.
One of the most important factors of our design is to make sure that we have proper water quality for the trout. For the project to be successful, we need great water quality as the fish will die out when the pH or anything changes in a big increment. These are the main factors that we are discussing for the water quality. Dissolved oxygen, the fish needs to be able to breathe, so we'll be using mechanical aerators, waterfalls, deflectors, and then we'll also have a backup aeration system. The next factor of water quality is the pH. To maintain a good pH from 6.8 to 7.8, we're going to put limestone within the stream, and this will keep the levels up. The next process that we'll talk about is the nitrogen cycle. We will be using biofilters to filter the water and then also to help complete the nitrogen cycle. So as all the grass and leaves fall into this stream, they'll need to be decomposed properly, and if there's not enough of the ammonia and nitrogen, this process won't be completed. The next process of water quality is if there's too much sediment in the water. Trout don't like silt, so to deposit the substrate, we're going to have a meandering stream so it doesn't all end up in the bottom of the pond. We're next going to talk about the design of the stream. This is the basic design, and there'll be a system of pools, riffles, runs, and then pools again, and they'll be equidistant apart. We're going to use a raised edge to prevent runoff from entering the stream, so it'll be 1 foot high compared to the outside, just so we get runoff going elsewhere. And then just like for the appeal of this project, we're going to use water gates, so we can trap the trout in a certain pool. And this will also be if there's a lot of rain, so we can control the velocities in the stream. So for our design process, we have a few alternatives, and one of the main ones we had an issue with was choosing whether 1 or 2 pipes would be used under the ground to cool the water. We ended up choosing 2 pipes. And another big alternative we had was to cool the stream mechanically or to not use mechanical means, and the sponsor did not want mechanical means, so in the end we cooled it without mechanical heating. And the last thing is the main impact of this project. So the main impact of this project is that this design is so large scale that it can be used for many other applications. It's not a small pond recirculator, so in the future there's a blueprint for other designs that